Okay, now we'll go directly to discuss some factors that may influence the effectiveness of the selection. As we defined the selection previously, we said or defined it as to select the individuals to be the parents of the next generations. And by selecting those individuals to be parent for the next generation, we give them the opportunity to distribute their genes and to increase their frequency among their offsprings and through the successive generations. So they have a good chance to increase it. But there is a little or some factors they may affect the frequency of the genes, of the favorable genes through generations. The first one is the current or initial gene frequency. So we do need to think about the frequency or the initial frequency for those favorable alleles or less favorable alleles that we do need to increase or decrease through the generation. And the second one is the influence of the effectiveness of selection is the degree of which the various genotypes and population differ in fitness. Those are the first two factors that may affect the selection. So we do need to think about the initial gene frequency and also the fitness. Before commencing in discussing the first and the second chapter or second factors, we do need to know what do we mean by the fitness or fitness traits. Generally, if you read any breeding books or references or articles, you may see fitness in all those references. So the fitness is the ability of an individual and its corresponding phenotypes to contribute offspring to the next generation, and this is the main definition for what you call selection in general. So we give them the ability or those individuals to be parent of the next generation, and also we give them the opportunity to the parents to distribute their genes and their phenotypes contribution to the offsprings or the next generation. The terms here refers to the number of offsprings or offspring an individual produces, not just the ability to be selected. So the larger the number of the offsprings produces from the main generation, main parents, it is the fitness. And also we may refer to the fitness as the fertility of those parents to be to produce more individuals in the next generation. So in some terms, we can define the fitness or fitness traits. It is the traits that related to the survivability of those animals. And it is not just only the survivability, not the ability to be selected or the survivability. It's also related to the fertility of those animals to produce new offspring. So we will take now an example related to the frequency or the selection against certain alleles that to be selected in the next generation or to be discarded in the next generation. We will take this figure, and this figure, as you see in the vertical bar, you can see the generation through 40 generation of selection, and also in the horizontal you can see the frequency of less favorable desirable allele, which is J2, and here we have J2, it is the second allele, and J1 is the first allele. Imagine with me that we are dealing with A capital, as we discussed in the class, that we have A capital and A small, and now we have J1 and J2. J2 is the less favorable allele. And if you observe this horizontal bar, you can see the frequency of less favorable allele or J2 is very high, which is the initial gene frequency for that to be selected for or against. Now, as we see here, it is about 95% in J2. It means that J1 is 0.05, which will be here in the near to zero frequency for the J2 or J1 frequency. And we can see the change in gene frequency of less favorable gene allele over 40 generations of selection. In this example, there is no dominance with respect to the fitness of the locus or J locus. Okay, no dominance. As you see, the solid line here represent large difference in fitness among hmm, among offsprings. And J2 as you see, relative to J1 individual, J1 J2 individuals usually produce 3/4 as many offsprings, and J2 individually produces half as many offsprings produces. Okay, as many offspring. The broken line, right, as you see here, a broken line in this figure represents smaller differences in the fitness relative to J1 individual, J1 J2, and produce 7/8 as many offsprings, and J2 produces 3/4 or 3/4 as many offspring. From this figure, you can conclude that through generations, and here we are selecting against J2 allele. The initial frequency is high for the J2 allele, and through generation we do need to reduce this frequency, the frequency of the J2. It will be diminished. It will be declined, as you see, through generation. From the third generation up to the fourth generation, we can see decline of about 0.1 frequency in the J2 allele. But when we reach the 13th generation, or from the 7th, 5th, or 6th up to 16th or 19th generation, you can see the reduction, high reduction in the J2 allele, which is not favorable in this case. And if you compare the two lines, as we see here, this two lines is related to the fitness trait. Fitness trait, it means the survivability, or the something as we defined previously. And this one is this fitness traits, and the broken one, the broken line here is favorable one, and you see that the survivability is very high. And since the survivability is high, the decline will be much lower than the other thing. So we discuss right here two factors that affecting the rate of genetic change through simply inherited traits. The first one, the initial frequency, and also the second one is the fitness trait. Also, if you observe that the fitness is very important for the selection, and also the initial, as we discussed, the initial gene frequency. The fitness here is very important, since we obtain many offsprings for a certain generation, in a certain generation. So we have the ability to select more accurately, and also the selection intensity will be much higher. But if you don't have a fitness, for example, if you have a few offspring per individuals, or few animals are born from certain family, and in this case we are obligated to select all those individuals at the basis of what they are. But the selection will be less accurate than having high fitness traits. Now, the third factor here is that affect the rate of genetic change in gene frequency at a particular locus, the degree of dominance expressed at that locus with respect to the fitness. And from this figure, you can see also the same. We have generation. We have a selection process that conducted for 40 generation, and also here we have the frequency of less desirable allele, which is J2 also in this figure. As you see, if we start by selecting against J2, and we know that J2 is gene frequency is very high, which is about 95%, and J1 is 0.05. You can see from this is change in gene frequency over the 40 generation. Differences in fitness among genotype are fairly larger when J2 is completely dominant. As you see, when complete dominance, as you see, J2 is complete dominant. This is the broken line. We can observe through generations that the selection is fairly relative. The fitness among when the fitness is between genotype or among genotype are fairly relative. when J2 is completely dominant with respect to the fitness broken line as we see here, and relatively it will be relatively to J1 individual. J1 J2 and J2 individual produces half as many offsprings with no dominance, which is the solid line as you see here. J1 J2 individually produces three quarters as many offsprings, and J2 individually produces half as many offsprings, or 50%. When J2 is completely recessive, which is the dotted line here, J1 and J2 individually produce equally as many offspring, and J2 individually produces 50% as many offspring. This is the main thing that we do need to know from this picture. As you see, if we select in complete dominance, now return back to see it in general discussion. J2 right here, if you go to J2 line right here, the broken line as you see here, and with a fair with fair fitness among the genotype, you can see the progress in selecting against J2 will be slower than the other things, the other genotypes, because it is completely dominant. J2 can cover, or it will cover the effect of the J1 allele, but through generations, and now the generation, and we are reaching here at least 22 generations. After that, it will be declined until reaching the high frequency for J1 allele. But if you compare it with the solid line, as you see here, the solid line is the no dominance. There is no dominancy. No dominancy. It means both of those alleles contributes equally to the appearance, or to the phenotype. You can see it is directly reduced compared to the complete dominance. The reduction is observed after 4 generations, or immediately, I think, after 2-3 generations, and to reach the high frequency for the J1 allele after by reaching 22, 23 generations. But in the first one, it is 34 generations, as you see, 33, 32, or 34 generation with the complete dominance. It will last for a long period through generations. But if you also compare it with the recessive of the J2 allele, the recessiveness, okay, the complete recessive with J1 and J2 individually produces equally as many offspring, because J1 will give us half of 50% of the, or J2 50% of the offspring, and the reduction in the J2 frequency will be immediately occur after 1 generation. After the first generation, if we have complete recessive, it's complete recessive, and after 10 generations, also you can see that the reduction will be also slower, but it will not reach 0 in recessive. Though it will be considerable frequency among the individual, but if you compare if you select against J2 in complete dominance and without dominancy and complete recessive, you can see the behavior or the gene frequency through generations that to be slower in the complete dominance, and also if you compare it with the no dominance and the recessive or completely recessive, it will be reduced after a few generations, not as the complete dominance.